Yeah, so as he mentioned, we're developers on IBM Watson Discovery, and this talk will cover some of the instances where we made mistakes that led to us getting paged, sometimes during the work hours, sometimes in the evening, sometimes in the middle of the night. And so as we go along, I'll be presenting the lessons we learned, as well as telling you some of the horror story of how we ended up having to ask ourselves the questions that we had to ask and learn the lessons that we did. And hopefully you can learn from the same things we learned from, just not having to go through it yourself. So before I start, I want to give a little bit of a background on our team. Our group is responsible for the natural language queries in Watson Discovery at IBM. And each of us goes on call, which we call pager duty, so I'll kind of use those two interchangeably. For a week at a time, we start Wednesday, middle of the day, to the following Wednesday, middle of the day. And the expectation is that we'll be available 24 hours during that period of time. And so with that kind of background, this first incident I'm going to talk about, or review, happened the first shift after we went live in production. It was Joe's first shift, and everything went smoothly. The evening comes, and he starts settling into bed when a flash of light and a siren pulls him out. They came not from outside, but from his phone. He jumps into action, looking at information from the alert that he received. The alert provides a link to step-by-step instructions on how to deal with the problem that's happening. Yes, this should be easy to resolve, Joe thought. Then he clicked the link. Our playbook is what he was brought to, and it's supposed to be a list of error codes that we can receive as alerts, and each of the error codes should have step-by-step instructions or a description of what to do when you receive that error code. Unfortunately for Joe, the entry associated with that error code was useless. It just had some generic information that didn't provide any information on how to fix the problem that he was seeing. He also discovered that a lot of the information was just difficult to find as he was trying to diagnose what was going on. We submit our logs and our metrics to a centralized system, and then we use Kibana and Grafana to view them, sometimes visually, sometimes just by looking through the logs. Joe couldn't find a link to either of those instances. Remember, this is the first time we went live in production, so we're still kind of figuring things out. And since this was the middle of the night, Joe wasn't even sure to ask who to ask or how to ask for assistance, since the rest of us were asleep. Joe is someone who likes to stay up really late. So, will Joe solve this problem? Will the mystery of the PagerDuty pages be solved? And the answer to both questions is yes. But the important thing for this talk is, what were the questions we should have been asking ourselves before this happened? Joe was wildly unprepared because our group, for various reasons, had minimal time to prepare for PagerDuty before releasing. Over the past year, we went live about a year ago, we gained a lot of experience that we've been able to use to build up our playbook. So we learned a lot from our mistakes. But what were the questions we could have asked before we went live, that would have turned Joe's frown upside down? The first one was, what is the on-call person's duties? The poor quality of our playbooks when Joe went on PagerDuty was just due to our lack of experience. But keeping our playbooks updated was a task that we struggled with during the first few months that we were on call. And this was because we didn't ask the question, what is the on-call person's duties? Instead, we just assumed that the only job of the person on call is to put out the current fire. As soon as our service went live, we quickly discovered there was more to it than just that. Updating playbooks with step-by-step instructions, like Joe wished he had for that first page, that would list how to deal with the problems that were occurring, turned out to be a much larger task than we had anticipated. The person on call also found themselves making changes to our logging and our metrics in response to the problems that we saw, so that we would have the information we would need next time it occurred so we could diagnose and fix the problem. Or if they found just information was lacking in the visualization of the metrics that we had, we'd have to make changes to the metrics visualizations as well, and so that would take up time again. And finally, someone needed to actually fix the root cause of the problem that was causing the pages. Being on call, particularly getting this page in the middle of the night, our goal is really just to get the service back up and running, sometimes with degraded performance, not necessarily fixing the underlying root cause. So first get it working and then fix the problem if you didn't as part of that process. Doing this often fell to the person on call because they were most familiar with the page that they had received. Sometimes it would fall to someone else more familiar with the service, but in general it fell to the person who received the page. Unfortunately, it took us months to deal with just how much the on-call person needed to be doing. Why did it take so long? Because no one really asked the question, how bad are things? We didn't really have a good communication channel for people within our own team for the on-call person to report to everyone else what had happened during the shift, particularly overnight. The on-call person would kind of tell the next person going on call, hey, here's what I dealt with over this past week. You might be dealing with the same sorts of things. And so you kind of get this chain, but after a week or two, the stuff that happened 2 weeks ago probably wouldn't get communicated to the person going on call for this coming week. So you kind of knew how bad things were for you, and to a lesser extent what happened before you, the week before you, but there was no kind of big picture of what was going on overall, what were all the problems that we were seeing maybe again and again and again. So the end result of this was that we were seeing the same problem over and over. We would come up with a quick fix that would fix the problem so we could go back to sleep, and the alert would stop. But as a group, we didn't prioritize the other tasks that we were doing while on page duty, necessarily fixing the underlying problem. And this was mainly because as a group, we just didn't know how bad things were because, again, we only kind of knew what was going on for us. So we needed a way for the on-call person to kind of communicate to the rest of the team as a whole what was going on and what the problems were. And eventually, we did deal with that problem. The on-call person would give a daily report to the rest of the group, even if the report was just, hey, everything was fine overnight, or everything was fine yesterday. Also, time was set aside formally each week for dealing with these on-call duties. This would regularly, reduce the effective manpower of our team by one person. But the case was made that this was necessary to keep people kind of sane and not dealing with pages overnight, every night, or every week. And we got management buy-in from that. We took a little bit of convincing, but we were able to get that. And so after a couple of months, we ended up with a much more stable service and the ability to actually get some sleep while on pager duty. In fact, as you can see here, we did such a great job, we were never paged again. Shortest talk, hopefully. Just kidding, actually. We got a lot of pages even after we addressed this problem. So with that, I'm going to move on to the next incident, or next story, where it paged at 5 p.m. It began at 5 p.m. on a Thursday when Michael, another guy on the team also named Michael, gets a page, and then another, and then another. There's an avalanche of pages coming in that he's receiving. He consults our playbooks and looks at the metrics visualizations, and he can see that some percentage of our incoming requests are failing. He recalls earlier in the day that we had deployed a new version of some of our microservices. So his goal, again, is to try and get things working, not necessarily fix the underlying problem. That can come later. And so he figures we just deployed something, let's roll back to what was there before, and that should hopefully fix the problem. So he decides to roll back to the earlier versions and expected the failed requests to stop immediately and the pages to stop coming in. Unfortunately, the problem actually got worse. The failure rate went up. He starts digging into the logs and discovers that some of the requests coming in to our microservices are disappearing. They never arrive at the next microservice in the stack. And what he starts to dig into, as he starts looking into this, he discovers that we're receiving messages, we're receiving things coming in, but then they're being dropped. What happened was that the platform team had done an upgrade beneath us, and the newer nodes couldn't talk to the older nodes. And so when we deployed, some of our services ended up on new nodes, some of them ended up on the old nodes, and they couldn't talk to each other. And that was why we were seeing those dropped communications, those dropped requests. So we again come to the question, what should we have been asking ourselves? Why was it so hard to figure out the problem, and what could we have done to make this easier on ourselves? So one of the problems we were dealing with was that we were treating each of our microservices as a chunk of code and not as part of our larger overall service. We were only reporting that an error had occurred downstream for the upstream services, but not necessarily which microservice had experienced the error and maybe even why it had experienced the error. Microservices at the top of the stack would just report failed, but wouldn't provide all the information that we would need to really diagnose the problem. And this was because we hadn't really thought, well, where should this happen? So on the slide here, you can see on the left-hand side, we ended up just kind of logging or reporting in our alert a stack trace of the problem, which could help as a developer. We could look at that and get a sense of where the problem occurred, but that would assume we knew everything else about the request. which we hadn't always been logging. And so on the right-hand side, the revised version was to stick in information to allow us to track the request that caused the page, and also provide some other information so we could kind of dig into, is this unique to a particular customer or something more general. And so stack traces can be helpful, but we found that we also want to include other information that could also help us kind of dig into what was going on in this whole ecosystem of microservices. All right. So another problem that Michael had as he was trying to diagnose the problem was that it wasn't immediately obvious from our Grafana visualizations what was going on. Our Grafana dashboards are based on metrics of our microservices that they generate and report, and then our initial dashboards that we had developed before we went live showed information that was valuable while we were developing our service, but as it turned out, it wasn't really helpful as we were actually diagnosing real problems. Because when we're on call, our goal isn't necessarily to solve the root problem, but just to make sure that service continues responding to requests, even if it does so with degraded performance. And so in this case, with this story, Michael needed to answer the 3 questions you see here. Is this problem impacting the customer, or is it just something behind the scenes that they're not necessarily seeing? Can I tell if the problem is intermittent or if it's systemic? And just, is my service even healthy? And so this is an example of a graph that we built after the service went live. With it, we can answer all of the questions from the previous slide. In fact, this shows us here that, I guess there's no key, but the green bars are telling us that there's a good response. So we're measuring the number of requests that we get in, and how many of them are good and how many of them are bad, how many of them are we able to succeed on and not. And so by looking at this, we can see that we are receiving requests, and a majority of them appear to be serviced correctly, but we are getting this low-level number of unsuccessful requests, or requests that we're not able to properly service. So from this, we can tell that there is a problem, and so the next step is to figure out what's causing the failed requests. And so you might say, okay, well, I'd like to know a little bit more about those small red bars. So wouldn't it be nice if we had another graph that grouped all those failed requests by the kind of failure that occurred, helping us kind of dig deeper into it without having to look into the logs themselves. And so we built another Grafana graph that would show that information. And so it's a little hard to see on the slide, but the graph itself would have, so we grouped the different failed requests into different types: already exist, not found, invalid argument, unavailable. And so again, it's not necessarily easy to see on this graph here, but we can see that a lot of the failed requests are of type not found. And so once again, we can kind of quickly look at this graph and see, okay, most of the problems are not found problems, and we can kind of dig further in or move forward with that extra information. And so ultimately, our goal is to quickly determine the state of our service and give us quick insights into where the failures are happening. We can now do this with the combination of what we have from the alert and from these dashboards that we build up from the metrics that our services report. So we know that our service is still servicing requests. That was the green bar with the first graph that I showed with the green and the red. Then we can also tell from the second graph that most of the failures are due to the not found error. And then we can take that information and the stuff we got from the original alert that I showed many slides earlier, and together we can use that information to filter the logs to kind of diagnose or dig into the specific problem that we're dealing with. So I've shown kind of solutions for 2 of the problems that Michael was facing. The third problem, though, that avalanche of pages that he was receiving, I'm going to talk about that in the context of the third story, or this third story here, where the problem came from the user. So it was a week like any other for Wental, another person on the team. Then they started coming. Microservice after microservice, issuing alerts. How could Wental quickly recover our microservices when everything was having problems? He used the alerts and the logs and our Grafana dashboards to quickly find the cause. A user had uploaded some relatively reasonable data, but due to a bug in our code, we were firing alerts every time they tried to access the data that they had uploaded. So there was a problem there that we did need to fix and we should have known about, or we should know about, but it didn't need to be fixed at 2 a.m. And it definitely didn't need to be fixed, or it definitely didn't need all of these alerts coming in that he had to kind of filter through and deal with. And so again, what were the questions that we should have asked so Wental didn't have to go through all of this? Why wasn't it easier to find the cause of the problems that he was dealing with? And why did we get so many pages about the problem instead of receiving just one? And so we received so many pages because we hadn't thought to ask ourselves the question of where we should issue the pages. We had been treating each microservice as independent when it came to paging, and so when a downstream microservice encountered a problem, it paged and returned an error to the upstream microservice. The upstream microservice would then receive the error and send out a page as well saying, I can't deal with this error. You need to fix whatever the underlying problem was. And so each of our microservices would be sending out their own page. And so for one problem, we could end up with many, many errors or many, many alerts. Instead, what we should have been doing was to decide where the page would be sent and then just send it there. It could be sent at the source, or it could be sent from the top level and just page in one of those locations. In some cases, in fact, you may not even want to page at all, and instead just record a metric that a problem had happened. And then you could set a threshold for that metric, and then alert if you exceed the threshold. And if the metric rises too high or gets too low, then you can set a page based on that. Otherwise, you can look into it during regular work hours. Take a look at the dashboards, see, okay, it's getting kind of high, it's getting a little bit lower. Maybe we should look into that instead of being woken up and having to dig into something that could just be a minor problem. But regardless of how you decide to page, this should be easily configurable. This was actually one of our major pain points, especially towards the beginning. We were overpaging in some cases, but to reduce the pages meant we would need to go in and change the code itself. Over the past year, we shifted away from direct paging towards metrics-based alerting when it was possible to do that. Because for us, at least, it was easily configurable, and we could easily change the threshold. And so doing all that didn't require a redeploy or changing the code at all. We could just change the metrics-based alerting instead of changing the code itself or changing the microservices. So kind of separating out the alerting from the services themselves. The other side of Wental's wave of alerts was that they were caused by customer data. And being able to quickly identify if a problem is localized to a single user or group of users versus being systemic is also extremely useful. In order to do this, we include information in our logs, which allows us to use Kibana queries to see whether a problem is localized to a customer or, again, if it's systemic. Our direct pages also include this information, allowing us to kind of link to the logs and dig down into the bits and pieces of the information. And by filtering on all this information, we can quickly get an idea of whether or not the problem is customer specific or if it's systemic. And so with that, it brings us to our next story, where it came from beyond the proxy this time instead of the user. Eric was on pager duty, and it was a dark night. He started getting page after page. Not an avalanche like we heard in the last two stories, but he still got a couple of pages here. Requests were failing as they came into our service. And so Eric leapt into action. He immediately tried to determine how bad the problem was. Our metrics dashboards showed that the requests were failing, but the problem was intermittent and just a small percentage of our total traffic. So again, on this graph, you can see most of it's green, little bits of red are in here. Due to improvements in our logging, he was quickly able to determine where the problem was. It was just a timeout error, and it was coming from one of our microservices when it was trying to make its own REST request against an external service. Eric rebooted our service, figuring that often fixes the problem, but it didn't seem to have an effect this time. After more investigation, he found out that parts of Watson Discovery that were also interacting with that external service wasn't seeing the problem, and so the plot thickened. As it turned out, the problem was a combination of us not setting the correct timeouts and the internal network between us and that external service losing traffic. And so the questions that we should have asked here were, again, why was it so hard to figure out the problem? What were the questions we could have asked earlier that would have helped us do better when the problem happened? So the first problem was that we had no retry logic between our microservices and that external service. And believe it or not, that was actually a design decision that we had intentionally made. We figured we're at the bottom of the stack from the user's perspective. So by the time the request gets to us, we go out to the external service and then kind of propagate our response back up and then ultimately send it to the user. And so we thought retrying requests could adversely affect the overall user request response time, because if we retry and the upstream services retry, then we're going to have a lot of retrying before we eventually send something back to the user. Other groups interacting with that same external service were using retries, and so they weren't seeing that problem. And so if we had asked ourselves the question, can we trust the external service, the answer would have been probably not all the time anyway. And so we want to make sure we can configure how defensive we are over this connection to that external service, and make sure that we can configure it at runtime and not just set it and then deploy and not be able to change it easily. So the biggest reason it took so long to track down the problem is that we couldn't even reproduce it. At first, we couldn't do this because we weren't tracking the request properly from the user all the way down to our lowest level. We include a transaction ID that's assigned to the request as it comes into Watson Discovery, and then that gets passed along to each of the different microservices handling it so that you can track the request throughout the entire Watson Discovery service. The bad news was that the particular log with that request timeout, or the timeout exception, didn't have it. That was just an oversight on our part. So there's no way to link the request to the errors that we were seeing. But we fixed that problem, and then we got to the next major problem, which was that we weren't even including enough information in the logs to allow us to reproduce the request from the user. So the users were seeing this problem, or some of them anyway, but we weren't able to reproduce it. We could, in some cases, we could have fixed this. We could have added that extra information in there, but in others, we couldn't due to user data privacy concerns. And so in those cases, we really should have still added some extra metadata to the logs that would let us approximate the user's request. And so with that, moving on to our last story, we had a different kind of communication problem. So who are you going to call at 2 a.m. when you have a problem? That was the question that another colleague of mine, Chuck, had when he had to figure out how to deal with a page. The error code indicated that something catastrophic had happened and all our microservices were failing across the board. He consults our playbook and finds that the entry for the error code has some information there. The playbook clearly defines step-by-step instructions on how to deal with the error. So this is a success from what we had learned earlier, but he quickly notices that something is wrong with our metrics dashboards. So this is what Chuck sees. The top graph shows successful requests, and the bottom one shows the number of errors. And over time, we would expect the number of errors to not increase because we're getting so many successful requests. But the graphs are kind of in contradiction with each other. He spends several hours trying to understand what's going on here. Why are we getting mostly successful requests? But we're also seeing a huge rise in the number of errors, requests that had errors as we were processing them. Is one of the graphs wrong? Are both of them wrong? Are we no longer recording our metrics correctly? It turns out that this was another case of the platform team upgrading things beneath us. In this case, the Grafana instance was upgraded, and this changed some of our visualizations so that they became aggregates instead of counts like we've been expecting. Unfortunately, it took several hours for Chuck to figure this out because there was poor communication between the teams. So Chuck likes to sleep, but he didn't get much sleep this night because of the problems. So what were the questions we could have asked that would have let Chuck sleep? First one was that who do we depend on? Our microservices depend on the efforts of many other teams within Watson Discovery, plus those outside of Watson Discovery. When we started on PagerDuty, we didn't know how to contact most of those other teams, let alone how to reach them outside of business hours. As problems developed, both during and after business hours, we built up knowledge of how to contact our dependencies. Now, Chuck discovered that this process can be extremely painful when you have a severe problem and you can't really contact people because it's after hours. Even during business hours, the process is slow and ad hoc at times, and so it's not uncommon to spend several hours tracking down the correct team to contact. The important point here is to establish the communication channels before you have a problem rather than as you're trying to deal with the problem. In fact, back in the story that I told about Michael, where it paged at 5 p.m., he experienced the same problem. He tried reaching out on the general Slack channel at IBM, and eventually he was kind of pointed to one team. That team said, you're not talking to the right team, you should be talking to this other team. And so this is a little bit after work hours, so there were still people able to help him, but he eventually did get pointed to the right team. But they couldn't help him right away. The right team to talk to needed extra information from Michael, from us, which took time to find and collect before they could start investigating things on their side. So in addition to establishing a communication channel between teams, we also should have determined what information they would want or that they would need so that they could help us resolve the problem that we were seeing. So we might be logging that information ahead of time, but we're probably not because we may not need the same information that they need. And so setting up and having a conversation, not just a communication channel ahead of time, turned out to be would have been a very nice thing to have. On the flip side of who do we depend on is who depends on us and what information would we like to have from those people. And so as a courtesy to our downstream dependencies, we reached out to them and kind of set up that same communication channel we did with our upstream dependencies. So we come to now to kind of like, what did we learn from today, or what did we learn over this past year of dealing with being on call? One of the things we learned is that we needed to have this communication channel for the on-call person and the rest of the team, just to let them know the problems that our service is hitting. So again, this is that within the team communication channel. This makes sure that everyone on the team has an idea of how well or how badly the service is performing. Once we established this channel on our team, it became obvious that the person's on-call duties needed to be expanded so that they could deal with everything that needed to be dealt with. This would be updating playbooks, this would be fixing logs and metrics or adding extra information there, and ultimately fixing the root cause of the problem, not just kind of putting a Band-Aid over it and letting things keep going. Again, communication is important because you also need to communicate with outside members of the team or other teams, tracking down who you need to talk to and what information they'd like to have kind of helps the whole Watson discovery, in our case, succeed instead of just our team succeed. And so we want to make those communication contacts during regular business hours when you're not dealing with a problem, when you have the time to kind of investigate who to talk to, and you're not under the pressure of how do I get the information I need as quickly as possible so we can resolve the problem. And then reciprocating for those who might need to talk to you. We also learned that we made debugging much more difficult than it had to be because we weren't treating our microservices as parts of an overall service. Each would page when it experienced a problem, sometimes causing an avalanche of pages, forcing the on-call person to first look through all of the pages, prioritize addressing them, basically triaging everything. And then, once he identifies what problem to deal with first, kind of starting to work on it. So triaging all the pages for the same underlying problem just wastes time that could be better spent on fixing the problem. We ease this issue by putting more information in the errors sent upstream, shifting from direct pages to metrics-based alerting, and making sure we track requests through the entire stack of microservices. Thus, we would just get one page about a problem instead of a bunch of pages, allowing us to start fixing the problem faster. When we started digging into a problem, we want to see all of the necessary information as quickly as possible. This is what our screens often look like when we're investigating a page. We have the alert on one side with all the necessary information about the problem, and then the right-hand side shows an example of our Grafana dashboards to give us an idea of the state of the microservice or the state of the service that we're dealing with. You'll need to decide what you'll log in your log messages so that you can trace requests throughout the system. For us, again, that meant including a transaction ID. Your log messages should also contain useful information about the request. Again, that's what all those different fields are on the left-hand side, just information to help us track what user it's from, as best as we can get that, what particular piece of information were they requesting, and so on. Again, kind of abstract, so we're not getting private information from the customer. The metrics should also be monitoring important actions of the system. For us, that meant counting things like the number of successful requests and counts of each type of unsuccessful request. Getting this all set up takes time, and you'll need to learn the tools and put time into actually configuring them to do what you need them to do. This is something that, in retrospect, we should have known, but we hadn't really thought about it until we were actually dealing with these problems. You also want it to be organized to quickly answer the important questions when there is a problem that you're dealing with. Spend time figuring out what the important questions are so that you'll know how to answer them when the time comes. Basically, though, the first 4 to 6 months are just going to suck as you're on call. Our mistakes caused an unmanageable level of grief for us. Hopefully, you can learn from these mistakes, at least learn from the questions that we realized we should have been asking ourselves so that you don't go through the same kinds of problems that we had to go through. And with that, I want to thank the rest of my team and then all of you for listening.
Great, thank you. Thank you, Michael. Any questions?
Have you ever been open to get
No, mostly because IBM is really particular about what we use. We don't really get to say what tools we use. Like the metrics-based learning we have, even if we set it up correctly, it'll say, okay, problem's over, let's resolve the page, and then maybe it's really intermittent, but it happens every couple of minutes, and so it'll alert us again and again. So we don't get to say what tools we use so much. We kind of just make do with what we have.
So, I mean, the thing is, it will really help you see your transaction across the virtual microservices, and as soon as you grow even more, you're going to have a lot more problems.
Oh, yeah.
So if you need that visibility, maybe you could kind of go back to business and say that, okay, you need that tracing.
It's a good point, yeah. I'm a little pessimistic that it'll work, but it never hurts, I guess, to bring it up to my manager and say, hey, this would help us if we have it.
So we face this problem pretty much every day, and the reason we can live with it is because of that tracing.
Okay.
Thank you.
Thank you.
So I just noticed that you're talking about reporting the bugs, but do you put into a bug report system? For a normal bug, you would have some kind of a tool that will track these things. So are you using that kind of thing?
We are tracking some of the problems to see how consistent they are, and they help us prioritize a little bit what services to focus on to improve. There was a talk earlier today by Michael Keeling, who's also on our team, where we talked about how we address the problem, how we ended up fixing a lot of our services based on lessons we learned, but we don't have a formal tool for that. It's mostly downloading the pages and seeing where the problems are, downloading the logs and which one produced the most errors. Yeah. I think there's another question behind you.
One last question.
Hey, thanks for the talk. It was great. I wanted to ask, you mentioned about setting aside time for the person who's on PagerDuty to actually deal with the other duties that go along and kind of cleaning that up. And
Yeah.
I just wanted to ask, and you mentioned it took some convincing, kind of what were those conversations like, and how did you get kind of the go-ahead to do that?
We found it's really helpful to have data behind what we're saying, because we could say, we feel like it's this, but they're not necessarily going to believe that. The management's not necessarily going to accept that. So we would do things like record how long did we spend updating our playbooks, how long did we spend releasing the new version of the metrics, things like that. So recording how long it takes us to do something. In fact, we're still arguing with them that our deployments take too long, and so we're recording data on that so that they'll let us spend time making that better. So it's really collecting data, building a cohesive argument based off of that data.
So it's empirically
Yeah.
driven?
Yeah,
Gotcha.
instead of just emotional. Yeah.
Cool. Thank you.
Thanks.
All right, I think time's up. I think that concludes this session. Thanks again, Michael.
Mm-hmm.